Good morning, one and all present here. I'm Nandhini, working as an assistant professor in the S College of Engineering and the Department of Computer Science and Technology. Today, we are going to see the topic on descriptive bivariant analysis and data analytics with R. An example is being given, and caloric intake X and weight Y is being given with the help of 2500 250 lbs, 2000 225 lbs, 1500 110 lbs, 250 1451 lbs, and 4500 380 lbs. A scattered plot for weight versus height has been given, height and weight. Weight has been declared 100, 120, 140, 160, 180, 200, 220, and height which is 50, 60, 50, 70, 70, 74, and 76. The descriptive bivariant analysis, it is organized according to the scale type of the attributes and the quantitative, nominal, and the ordinal. When one of the attributes have a pair is quantitative, that is nominal or ordinal, and the other is a quantitative, box plots can be used. Next one is the two quantitative attributes in the data set whose objective have n attributes. Each objective consists of a respective n dimensional space, a space with n axis, each of the representative one of the attributes. The position occupied by an objective is given by the value of the attribute. There are several visualization techniques that can usually show the distribution of points with the two quantitative attributes. One of these techniques is an extensive of an historical called a three-dimensional histographical. Two-dimensional attribute consists of a frequency and a weight and a height. With a 3D histogram for the attribute of a weight and height is displayed in this image. Next one is a two quantitative attributes, weight versus height, height in a centimeter, weight in kgs. Scattered plots for the attribute weight and the height has been given. With the height of 150, 160, 170, 180, 190, 195, and 200 with the increasing of 5 units. This is a 50, 60, 70, 80, 90, 100, 110, 120 with the weight kgs are increasing with the tens and units. So the scattered plots are being given here. Next one is a two quantitative attributes. How an attribute varies when a second attribute is changed by the covariant between them. When the two attributes have a similar variance, the covariant have the positive value. If the two attributes varies in the positive value, the covariant is negative. The value depends on the magnitude of the attribute. If they seems to be having independent variation, the covariant value tends to zero. It must be observed that only linear relations have been captured. The variance can be seen as a special case of covariant. It is covariant of an attribute which is itself has been given with the help of a derivative. Covariant between two attributes A and B, a positive correlation, negative correlation, a lack of correlation between explain A denotes a positive correlation, variable A and variable B, which triangles of a straight way. Next one is a negative correlation, variable A, variable B, in a right side variation, in a variable no correlation, variable A. There is no correlation, it is in the form of a triangle. So variable A and variable B is in the form of correlation. This is those are three examples of correlation between two attributes. Correlation between two attributes. The correlation always the linear correlation between the attributes. If the points are in increasing linear, the person correlating coefficient a value of 1. The points are in a descriptive line, its value will be -1. A value of 0 is when the points are a horizontal line or a cloud without any increasing or decreasing tendencies, meaning the non-existence of a person correlated between the two attributes. Positive values mean the existence of a positive tendency between the two attributes. A correlation has been given. Now, correlation between two attributes. The rank value of attribute of weight and height, 1.0, 1.4, 2, 3, 3, 4, 5, 5.5, 6, 6.5, 7.5, 7, 9, 8, 7.5 is 9.5, 1, 1 is 9.5, 10 is 11, 12 is 12, 14 is 13, and 13 is 14. X versus Y is given in the form of a scattered plots for the attributes X and Y. Two quantitative attributes, at least one of the nominal. And the attributes of both quantitative with at least one of the nominal category tables are used. Cognitive tables represent the joint frequency, calculating the identification of interaction between the two attributes. They have a matrix-like format which cells is in a square and are labeled at the left and the top. On the right most column or the total three row, while in the bottom most row or the total three columns. The bottom right hand corner has the total number of values. Cognitive table with absolute joint frequency for company and gender. Company is good or bad. Gender is male and female. Good is 6 and bad is 2. Female is 1 and 5. Bad. Gender is male and female. Bad and good. Super out. This is known as continuous table with absolute joint frequency for company and gender. Next one is two ordinal attributes. Spearman's ranking correlation should be used instead of the Spearman's correlation. Scattered plots with ordinal attributes usually have the problem that there are any values falling at the same point, making it impossible to evaluate the number of values per point. In order to avoid this problem, some software packages use the jitter effect, which added a random deviation to the values, making it possible to evaluate how larger the cloud is. Consequence takes can be used and master plots too. The values should be in increasing order. Thank you so much.